Hello again, grade 7s. In today's lesson, we are going to continue our discussion of circles. And this time around, we're going to do so by introducing a new physical quantity called the circumference of a circle. And then we're also going to do some calculations for the circumference of a circle based on whether we know the radius or diameter. Learning outcomes for today are to 1. Describe the relationships among radius, diameter, and circumference, and 2. Relate circumference to a value that is called pi. Okay, so the circumference of a circle we're going to represent with a capital C. I know in the last lesson I used the capital C to represent the center of the circle, so maybe we're just going to have to switch that terminology around a little bit to not confuse the two things. The circumference of the circle is essentially just a measure of the distance around the outside of the circle. So let's look at an illustration. First things first, again, just because I don't want to confuse circumference, capital C, with the center of the circle, maybe instead of calling the center of the circle capital C, now we'll just call it M. We can think of like M as being like the middle of the circle. What exactly is the circumference of the circle? Well, think of it like this. If you took a piece of string and you took that string and you wrapped it around the outside of the circle, one time, that would represent the circle's circumference. So essentially just the distance around the circle one time. Another way I might word it would be the perimeter of the circle, although I don't know if you use the word perimeter with respect to a circle. When I say a perimeter, for example, if you have like a triangular shape, a perimeter would just be the total distance around the outside. So you could also use a string to measure perimeter of a triangle. You could just put it around here, around there, and also around the bottom of that triangle. So the circumference, I suppose, could just be the perimeter of the circle, which is the distance around one time. The circumference of a circle is a linear measurement. When you see that word linear, you should be thinking of a straight line. And linear measurements you can make with a ruler. Now, you might be wondering, how could you possibly take a ruler and use it to measure the circumference? Because you'd have to bend the ruler around into a circle, and odds are the ruler would snap. Well, if you take that string that goes around the circle, say you want to determine the circumference, and you did that by wrapping a string around it, and then let's say that you unfolded this string into a straight line, then you could take a ruler with its little markings on it, and then you could actually measure the circle circumference. So in a sense, it can be a linear measurement if you did take a string, wrap it around the circle circumference, and then unfolded it, and then you could use a ruler to make that straight line measurement. To calculate the circumference of the circle, there are a couple different equations we can use. One equation we have, this is probably the most common one that people memorize, is the circumference of a circle is equal to this funky symbol, which we'll talk about in a moment, is the Greek letter pi, times d, where d is the diameter of the circle. And once again, the diameter of the circle is just the distance from one side of the circle to the other, passing through the center. We can also calculate the circumference of a circle if we know the radius, and in which case, this would just be the circumference of a circle is 2 times pi times r. This is a really easy way to go from the equation on the right to the one on the left. What we know is that the diameter of a circle is 2 times the radius. And if you plug it into the top equation, you can actually get the one that tells you the circumference is 2 times pi times r. But we do need to talk about this letter pi. So what is it? Pi is a value that we can calculate if you take the circumference of a circle and divide by the diameter. Whenever you see this word ratio, a ratio is typically making a reference to a division calculation. Therefore, pi is a ratio of the circle circumference to its diameter. Here's the interesting thing about a circle. It doesn't matter how big the circle is. It could be this really large circle we see up here. It could be like a really small circle. It could be like a medium-sized circle. If you take the circumference of any of these circles and you divide by the diameter, it is always going to give you the same numerical value. And that numerical value, and we just written down a few digits here, 3.14159. It actually keeps going on and on and on and on and on. There's actually no pattern to how it repeats. That's called pi. However, we can estimate this. If you want to do a really, really rough estimation, what I could do is I could just round this down to the nearest whole number, in which case pi would. And you can see right here I have these little tiny squiggly lines. So if you have like horizontal equal signs, it means it's directly equal to. If you have little squiggly equal signs, it means it's approximately equal to. That's a bit more rounding than we probably need to do. Typically, when people do calculations with pi and they round it to 2 decimal places. Therefore, pi would be equal to 3.14. And I think that's the number we'll kind of just stick with when we do our calculations. Pi is 3.14. Although if we did really want to just estimate pi, we could estimate pi by just turning it into 3. Okay, let's do some calculations. So example 1, I want to calculate the circumference of a circle with the following diameters and round to the nearest tenth of a decimal place. So I have A has a diameter of 40 millimeters, B a diameter of 12.6 centimeters. So first of all, we need to identify which equation is the correct one to use because we have 2 equations to calculate circumference. One of the equations tells me that circumference is equal to pi times the diameter, and another one tells me the circumference is equal to 2 times pi times the radius. Well, we're given the diameter in these problems d, so we want to use the first equation. To show correct work for this, let's use that 3-step procedure. So the way we want to do that is step 1, write down the mathematical equation. So that equation is c is equal to pi times the diameter. That's step 1 of my 3-step procedure. Step 2 is we want to do a substitution. So we want to replace pi with a numerical value and d with a numerical value. So this would then turn into c would be equal to, well, let's just round pi to 2 decimal places, so 3.14, and then multiply by, so we've replaced pi 3.14, and we're going to place the d with 40 millimeters. Let's plug that into our calculator now. So if we have 3.14 multiplied by 40, that gives me, it actually, if you type it in exactly like this, it gives you a number to the nearest tenth. So you don't even need to do any rounding. So 3.14 times 40 millimeters would be 125.6. And let's make sure to include the units of measurement. So when we sub the number in for diameter, diameter is a linear measurement. It has units of, in this case right here, millimeters. And the circumference is also going to have the same units as the diameter, so millimeters. Second one, I have D is 12.6. So again, let's do my 3-step procedure. So I have C is equal to pi times the diameter. And then let's plug the numbers in. So this would be C is equal to 3.14 multiplied by the diameter, which is 12.6 centimeters. So again, step 2 is just replace pi with 3.14, the d with whatever value it is, and now let's do a calculation. I suspect this one's going to have more decimal places than the other one. So 3.14 times 12.6, this is the number I get. I get 339.564 centimeters. However, the problem wants me to round to the nearest tenth. So the way to round to the nearest tenth So the nearest tenth is the first decimal place. To correctly round, we have to look at what the number is in the hundredths position. If the number in the hundredths position is 0 through 4, we don't do any rounding. We'd keep it as a 5. If it's 5 through 9, then we need to round up by 1. So we can see here that the hundredths position has a digit that is 6. Therefore, that's going to make this 5 round up to a 6. So this would turn into 39.6 centimeters. Let's go to example 2. I want to do the same thing, calculate the circumference of the circle, but this time we're given radii. Okay, so now we need to use a second equation because we're given r instead of d. Although if you wanted to, you could calculate the diameter and just go ahead and use the first equation if you wanted to, but that'd be a lot of work. So if you wanted to, you could go d is equal to 2 times r. Then once you have the diameter, you could plug it into the c is pi times d equation, but there's no really need to use that. We can use the other equation. Okay, so if we have the radius, circumference would be equal to 2 times pi times r. So again, 3-step procedure. First step, write down the equation. Step 2 would be plug the numbers into the equation. So 2, we're going to treat pi as 3.14, multiplied by r, which is 8 centimeters. And again, when you sub the radius or diameter in, make sure to sub the units in as well. And then that would be c is equal to, let's calculate it, 2 times 3.14 times 8 would give me 50.24 centimeters. Let's check out the rounding here. So we're going to round to the nearest tenth of a decimal place. Look at the hundredths position. It has a digit 0 through 4. So if it's digit 0 through 4, you don't do any rounding. So that would just keep it as a 2. So it'd be 50.2 centimeters. And we'll do one more. So we have r is 32.6 meters. So again, write down our equation. Step 1, 2 times pi times r. Step 2, do a substitution. Replace the pi with 3.14. And then replace the r with the 32.6 meters. Let's see, when we calculate this, I suspect I'm going to get some more decimal places here. So 2 times 3.14 times 32.6 gives me 204.728 meters. So let's check out the rounding. I want to round to the nearest tenth. So I need to look at which digit is in the hundredths position. It's a 2. So that's digits 0 through 4. Therefore, we don't need to do any rounding. So this will just turn into the circumference is equal to 204.7 meters. And that's it. So we talked about what the circumference of a circle is. We also talked about what pi is in relation to a circle, and we did some calculations for circumference based on pi, the diameter or the radius. Homework to complete would be in the MathLink 7 textbook, pages 278, numbers 3 through 10. I just wanted to point out one thing. In a bunch of the questions, it says estimate and then calculate. Well, if you did that, you'd have to do 2 separate calculations. The estimation would be treating pi as 3, and the calculation would be treating pi as 3.14. There's no reason to do 2 separate calculations, so just ignore the estimate part and just calculate. And again, we're going to calculate. That means we want to use pi as 3.14. Okay, so you can complete those, and then in the next lesson, we'll talk about how to calculate the area of a circle.